Welcome and thank you for joining. In this lesson, we'll explore limits. To start with, let's take a look at this little story about limits that will help us understand the meaning and the definition of it. Remember that very often when we solve word problems in math, we have to evaluate a function at a specific point. As an example, I brought in this very humble equation of a first-degree polynomial function, f of x equals 2x minus 3. We're asked to evaluate it at 4. So what that means is we're trying to find f at 4, which means that on the other side of the equation, wherever we see x, we replace it by 4, and then we evaluate. We have 2 times 4, 8 minus 3, 5. Therefore, we're going to say that the value of the function at 4, or f of 4, equals 5. So this entire process of evaluating the function at a specific point can also be described as taking the limit of the function at that point. And the way we write this is the limit of the function f of x as x approaches 4, which we can also write it as limit as x approaches 4 of 2x minus 3, that's the equation of the function itself, equals 2 times 4 minus 3, which is 5. Therefore, we're going to say that the limit of the function f of x as x approaches 4 equals 5. So as you can see, both the value of the function at 4 and the limit of the function at 4 equal the same number. Not only this, but the process of evaluating the function at 4 and finding the limit of the function at 4 is pretty much the same. In such cases, we say that the function is defined at x equals 4. And I'm going to throw in another word here that we are going to use very often. We say that the function is determinate and the limit is determinate at the expected point, so at x equals 4. Now, as you can see, we are practically talking about the same process, the same values for the same function. So you're probably wondering, so if finding the limit of the function is the same as if finding the value of a function at a point, then why do we have to learn limit? Why do we have to use limit? As a matter of fact, there is more meaning to the concept of a limit than just a simple evaluation of a function at a point. And to illustrate this, I brought in the equation of this rational function, x squared plus 4x minus 12 over x squared minus 2x. We're asked to evaluate it at x equals 2, which means that we have to find g of 2. So, fraction. Instead of x now we have 2, so 2 squared plus 4 times 2 minus 12 over 2 squared minus 2 times 2. So what we have in here is a 4, 8, together 12 minus 12, 0. So the numerator is 0. The denominator, we have 2 squared 4 minus 4, that's 0 as well. So 0 over 0 is undefined. So therefore, we are going to say that the function g of x at 2 is undefined. So g of 2 is undefined. Now, if we were to use this equation to solve a specific problem, I cannot, and I don't want to make up a problem here, but say that we want to find out the value of the function at a point and we find that it's undefined, it will be in best interest sometimes to find what the estimated value of the function will be around x equals 2. So even though we don't have a value of a function at 2, we need to know an estimated value of the function around 2 so that we can at least predict what's going to happen at that point. So what we do in this case is, to get an estimated value of y, is we approach number 2, or x equals 2, from the right and left hand side to see what happens and what the values of y will be around. So I'm going to bring in the Desmos chart. So I prepared this on Desmond, so let's take a look at it. It's faster. So when we approach x equals 2 from the right-hand side, so as an example here, I took 2.5, 2.1, and you see how the values of y start stabilizing, and as we get very, very close to number 2, x equals 2 from the right, the value of y becomes 3.999. So here is the graph of the function, and if we are getting closer to x equals 2, you see that the values of y are getting very close to number 4, in other words. So I'm going to write this down here. And we're going to say that this is approximately equal to 4. Now, similarly, what we're going to do is approach x equals 2, this time from the left-hand side. And from the left-hand side, it means that we're giving x the values 1.5, 1.9, and we're reaching even closer to 2 from the left-hand side, 1.999. And you see that the values of y are 4.0001. Now, what is happening in this case, here, at x equals 2, you see that the function is undefined and the graph of the function will show a hole or a break in here. So we're going to say that when we approach the function at x equals 2 from the left-hand side, then the values of it will become 4.00001, or we're going to say approximately equal to 4. As you can see, when we approach the function from the right side of x equals 2 and left side of x equals 2, the values of y will aim towards the same value. So we'll aim towards number 4. So in this case, we're going to say that, yes, the function is undefined at 2, but around x equals 2, the estimated values of y would be the same, equal to 4. We call this the limit of the function at 2. So the function is reaching a limit means that it is approaching a certain value. So it doesn't necessarily mean that it has that specific value, but it is approaching a certain value. So as you can see, the function may be undefined at a point. So g of 2 was undefined, but the limit of the function, when x approached 2 from the right-hand side, was the same as the limit of the function when x approached 2 from the left-hand side. So since the values of two limits, or estimated values of y, were the same from the left and right-hand side of x equals 2, we say that the limit of the function at x equals 2 equals 4. So even though the function is undefined at a point, we're still able to estimate the values of it at the point, and that estimated value is what we call the limit of the function.